Hi guys, this is Gopika here. So let's continue the topic of logical connectives. In the last video we already discussed about two connectives. The first one was negation and the next was conjunction. Negation was a unary operator and its keyword was not. By adding or removing not we can negate a statement. Okay, and the next was conjunction and its keyword was and. When you join two statements using and, then we can call the resultant statement to be conjunction. Okay, and conjunction is a binary operator. Now let's see the next logical connective. Okay, disjunction. So in conjunction the keyword was and, right? So here in disjunction the keyword is or. So if two statements are wait, before starting let me take the point. Okay, so if two statements are combined by using the logical connective or, then it is called as a disjunction. Now in other words, if P comma Q are two statements, then P or Q is called as disjunction. Now it is denoted as P or Q. This is the symbol used. Okay, and it is read as P disjunction Q or P or Q. Okay, now the note here is the disjunction P or Q is false if and only if both statements P comma Q are false. If both the statements are false, only in that case disjunction is false. If either of them is true, then the disjunction has to be a true statement. Okay, so the truth table will reveal something like this: T or T is T, T or F is again T, F or T is also T, and F or F is F. So only in one case disjunction is false. That is when both the statements are false. In all other three cases the disjunction is true. This we will understand better when we see the examples. Okay, so let's see the example. First example is P or Q. P is 2 is an even number and Q is 2 is an odd number. So the disjunction will be read as 2 is an even number or 2 is an odd number. Now here P is a true statement, that means this is a true statement, and the second part is a false statement. However, if you read the whole statement, 2 is an even number or 2 is an odd number. This or, when this or comes, the whole statement is claiming either of these statements. It does not claim both at the same time. So if it is claiming either of them, then this is a true statement. Hence, as a whole, this statement is also true. So disjunction is true when at least one of the statement is true. Okay, so this is a true statement. Let's see another example. Here P is 2 is an even number, same, and R is 3 is an odd number. Okay, now here both the statements are true, so obviously the disjunction is also true. 2 is an even number or 3 is an odd number. Okay, here or is claiming only one of the statement at a time, still both are true, so the whole statement has to be true. Now let's see an example where both the statements are false. So S or T is, S is 2 is an odd number and T is 3 is an even number. Now here both the statements are false, so the disjunction is false. Now though or is claiming only either of them at a time, but here both are false, so there is no chance of it, the whole statement being true. Hence this disjunction is false. So only both the statements are false, disjunction is a false statement. Okay, clear? Fine. Now let's see the next connective. Conditional or implication. Okay, implication is another word for it. Okay, now if two statements P comma Q are combined using the connective if then it is called conditional. Now if you observe this line, in this line itself I am using this if then connective. If two statements are combined using the connective, then it is called conditional. So here P is two statements are combined using the connective if then, and Q is the combination of that two statement is called conditional, is Q. So here also I am using if then connective, two statements, joining two statements. Okay, this is an example itself. Now it is denoted as P, write an arrowhead pointing towards Q, starting from P towards Q, and read as P implies Q, or if P then Q. Okay, now let's see the note. The most important part of all these logical connectives is this note, because from this note we can make out the truth table. So let's see the note. The conditional statement P implies Q is false only in one case. Which is that case? When P is a true statement and if it implies a false statement, then the whole conditional statement has to be false. So T implying F is F. In all rest cases the conditional statement is true. So let's see the truth table. T implies T is T. T implies false, that is T implies F is F. F implies T is again T, and F implies F is also T. So only when a true statement implies a false statement, the implication is false. In all other cases the implication is true. Now let's see a few examples and understand it better. Okay, before examples, let's understand something more about implication. In the conditional statement P implies Q, P is called hypothesis and Q is called conclusion or consequence. Okay, P is called hypothesis or antecedent and Q is called conclusion or consequence. And there are more interpretations of conditional statements, and those are, now P implies Q, or P is sufficient for Q. Then next is Q is necessary for P. Then this already we said, and one more, Q follows from P, and last one is P only if Q. All the statements mean the same, but they are different way of saying P implies Q. Okay, so now we can move on to the examples. Okay, so let's say the first example. P implies Q. If 4 is an even number, then it is composite. Here P is 4 is an even number and Q is 4 is a composite number. Okay, and when you join it using the connective if then, it will be read as if 4 is an even number, then it is composite. Now here the hypothesis, that is P, as well as the conclusion, that is Q, are true statements. Hence the implication has to be true. Okay, now let's see the next example. Here R implies S. R is 2 is an even number and S is 2 is a composite number. When you join it using if then, if 2 is an even number, then it is composite. Okay, now here R part is, that is the hypothesis part, is true statement, whereas the conclusion part is a false statement. A true hypothesis should not lead to a false consequence or false conclusion. If that happens, then the implication has to be false. So T going to F is false. Now next example is T implies U. Here T is, if 2 is an odd number, then it is prime. Now 2 is prime is the conclusion part, which is true, whereas 2 is an odd number is the hypothesis part, which is false. however the implication is true. Okay, f going to t is t, t going to f is f, t going to t is t. Now let's say the final case, that is both are false statements, that is the hypothesis, which is 2 is an odd number, and the conclusion part, which is 2 is composite. Both are false statements, however here too false going to false is a true implication. Okay, now let's move on to the next logical operator or logical connective, that is double implication. Double implication, or in other words we can call it as biconditional. Now if two statements are combined using the connective if and only if, then it is called biconditional. Okay, biconditional means, just before this we learned what is conditional connective. Biconditional means there is condition from both the sides. P is also applying a condition on Q, and Q also will apply a condition on P. From both the sides if there is implication, then we call it double implication. Okay, and the key word or key phrase that we will use is if and only if. Okay, now it is denoted as, if you can see, P double headed arrow Q. Okay, and read as P if and only if Q. This IFF is abbreviation or short form of if and only if. So P if and only if Q, or P biconditional Q. Okay, both the ways you can read it. Now there is an important note over here. Biconditional statement, that is P implies if and only if Q, is true if both P and Q have same truth values. That is, if both P and Q are true, then the double implication is true, and if both P and Q are false, then the double implication is true. But if they have different truth values, then the double implication will be false. So if the truth table, if you see, T biconditional towards T is T, then T double implication with F is F, and F double implication with T is F, and again F double implication with F is T. So when both the truth values are same, the biconditional statement will be true. Okay, in rest two cases the double implication or biconditional statement will be false. Okay, now let's see the examples and try to understand. Okay, so let's see few examples. First one, P if and only if Q. 4 is an even number. This statement P. 4 is divisible by 2 is statement Q. We have joined it using if and only if, that is the biconditional connective, and we get 4 is an even number if and only if it is divisible by 2. Here both P as well as Q are true statements, because 4 is an even number is true and 4 is divisible by 2 is also true. Hence the double implication is also true. Okay, T double implies T is T. Fine. Now let's see an example where one of the statement is true and the other one is false. So here R if and only if Q, R is 4 is an odd number, and statement Q is 4 is divisible by 2. So 4 is divisible by 2 is a true statement, however 4 is an odd number is a false statement. Here one statement is false and one statement is true, hence the double implication is false. Okay, now let's see the next example. R if and only if S. Now R is 4 is an odd number, and statement S is 4 is not divisible by 2. So when we read it together, it will be like 4 is odd number if and only if it is not divisible by 2. Okay, now here both statements are false, however the double implication is true. Why is that so? If you think, though both the statements are false, this double implication is actually, it cancels out the contradictions, and finally when you read the statement it appears to be a true statement. Okay, I hope you got the why the truth table of biconditional was like that. When both the statement have same truth values, then the double implication is also true. And when both the statements have different truth values, then the double implication will be false. Okay, so this was the last connective which I was supposed to discuss, and I'm done with this video. And in the next video we'll be discussing about statement patterns, statement letters, and logical equivalence. Okay, so thank you for listening to me, and if you like the video, please share it with your friends, subscribe the Friendter channel, and see you soon. Bye.